What is up, team? Welcome back to another video. This one is going to serve as a quick review over the functions final that we're going to have at the end of this week. And for that, let's just jump right in. So this functions final is going to have a couple different components to it that I'm going to look to see if you can execute. The first one is simple evaluating a function. We'll talk more about that in just a second. And then we're going to move forward with adding and subtracting functions. Doing those operations, and then being able to multiply functions is going to be another one. And then ultimately, we're going to be able to display an understanding of the composition of functions. And that'll be it. Oh, and a little bit of factoring. A little bit of factoring. And so when we go through this is going to be asked of you a couple of ways. First and foremost, the adding and subtracting and multiplying of functions will be displayed through some sort of polynomial form. There's another video on that if you'd like to take a look. I'll make one later today, and I'll do another example so that way you can take a look at it. And then evaluating a function will just be straight up procedural. So I'm just going to ask you straight up, can you do it? Composition of functions and factoring will be a little bit integrated. These will be kind of your level 3, 4 pieces based off of the polynomial form. And then there's going to be a certain way that they're asked, so that way you could demonstrate your understanding. Okay. So for this video, we're just going to do a couple of these. We'll do the first 3 or so, evaluating a function, adding and subtracting and multiplying. And then later today, you'll see more of a composition of functions and a factoring video. Okay. So let's do an example here. Evaluate the function at x equals -2. And so let's give us a function here. We'll do f of x equals x squared minus 3x plus 2. And we want to look at this at x equals -2. So when we evaluate a function, all we're doing is plugging in and simplify. And so for this problem, we're going to take this function f of x equals x squared minus 3x plus 2, and we're going to evaluate this at the value of -2. And so then this would mean that everywhere we see x, I like to put a set of parentheses so that way I can organize my thoughts. Everywhere we see that x value, we're going to be plugging in -2. So we have -2 here. That's what we're evaluating at. We have -2 here, -2 here. And then we can start simplifying this. So we'll get f of -2 is going to equal -2 squared means that we have -2 times -2, which means that we have a +4. And then we have a -3 multiplied by a -2, which means we have a +6 plus 2, which means f of -2 equals 12. Okay. So something like that would be evaluating a function. Then they can get a little bit more tricky. So let's say we do the same thing. We want to look at g of x, we'll call it g of x, equals -x cubed plus 2x squared plus 3. They look a little bit more tricky, and I want to evaluate this at g of, let's say, -3. And so we get a little bit trickier here, so we just have to slow it down a little bit and then organize our thoughts. So we get g of x equals -x to the third power plus 2x squared plus 3. And then everywhere where we see x, we're actually going to be plugging in -3. And so notice what I did right there. You may have overlooked it already. But here, this set of parentheses right there does not have the set of parentheses already. The way that it was written, it does not have a set of parentheses around the negative x value. And because there's no set of parentheses around there, we can't assume that it's negative x cubed. It's just the negative value is out in the coefficient term. So that's where I need to keep the negative out in the coefficient. And so then from there, I can then start plugging in negative 3. So I'm going to go like this. We get negative plus 2 squared plus 3. And I'm going to put in negative 3 everywhere where I see a set of parentheses. Now, this is where students are going to also get messed up because you see a negative and you're like, that's a positive. But we need to remember that we have PEMDAS as our order of operations, with multiplication and division taking the same precedent, and then addition and subtraction taking the same precedent. So we need to make sure that we work through all sets of parentheses. Let's simplify. Okay, well, we have x and x, negative 3, negative 3. I can't simplify that anymore, so we're good. Exponents come next. So therefore, when I simplify this, I don't do anything with this negative out in front because this term here, actually, let me go like this really quick. This term here actually needs to be simplified first. So this is negative 3 times negative 3 times negative 3. Then there's a negative out in front of that. So we'll get g of negative 3 equals, well, negative 3 times negative 3 is a positive 9, times a negative 3 is going to be a negative 27, plus, similar to over here, we're going to have a 2 out in front. 2 times negative 3 squared is negative 3 times negative 3, which is positive 9, plus 3. So I'll get g of negative 3 equals, now we can go to the multiplication division, whichever one comes first. And here it's all multiplication, so we'll get negative times a negative, which is a positive 27, plus positive 18, plus 3. So g of negative 3 is going to equal 48. Okay. So there's a quick couple examples of how to evaluate a function at a specific value. Some of these are going to be a little bit trickier than others, but hopefully you'll have the opportunity to do okay. So the next couple of examples we're going to look at are operations with functions. And so for this, we're just going to use the same kind of set of functions here. So we're going to have f of x equals, we'll call it 2x squared minus 3x plus 7. And then we'll do g of x equals negative 3x squared plus 4x plus 9. Okay. So here we have two sets of functions. And there's going to be a couple examples. We're going to add, we're going to subtract, and we're going to multiply. And so for this, there's a couple different notations that you may see when we need to add or subtract. So the first example is adding. I may just tell you, what is f of x plus g of x? Or you can tell me that, right? Especially if we're doing a polynomial form, which you'll see later today, f of x plus g of x. So what does that look like, right? Subtraction, and this, I'm going to go back to this really quick. This is actually also the same as g of x plus f of x. So those two, they can work out. Subtraction, on the other hand, gets a little bit tricky because you can have f of x minus g of x or g of x minus f of x. And these two are not equal to each other, depending on what the functions are. They may be equal in like one or two cases, but not all the time. Okay. And then when you multiply, f of x times g of x, that should be the same as g of x times f of x. Okay, so we'll go through a couple of these examples and take a look. Okay, so in this first one, when we're adding, Let's say we do want to look at f of x plus g of x. Okay, so in this example, let's do f of x plus g of x, which means that we're going to need to take both of these functions, the first one and the second one, and then write them out in a way where we can add them together. So we'll get 2x squared minus 3x plus 7. And then I like to keep the first one outside of the set of parentheses, but then put the second value in the set of parentheses. So we'll have a negative 3x squared plus 4x plus 9. And you'll see why I like to put that set of parentheses only around the second value once we get to subtraction. Okay, because then the first step that I want us to accomplish here is actually starting to be able to simplify this. And so we'll have 2x squared minus 3x plus 7. Then now we need to do this fun activity of distribution. Now, distribution won't be that difficult here because it's an addition sign, so everything will stay the same. But just to show you what I'm doing, a positive multiplied by a negative 3x squared is going to be still negative. So we're just going to get minus 3x squared. Positive and a positive 4x are going to still be a positive 4x. Positive and a positive 9 is still going to be a positive 9. Now, in this case, you can combine like terms. Everything that has an x squared gets put together, everything that has an x gets put together, and everything that has no x's can be put together. Okay. So we have 2x squared minus 3x squared minus 3x plus 4x plus 7 plus 9. So I essentially just took each of these terms and I moved them to be near their partners. So that way we can easily combine like terms here. So we can combine all of this, we can combine all of this, and we can combine all of that. So my final answer here will have f of x plus g of x will give me a value of negative 1x squared plus 1x plus 16. Because 2 minus 3 is negative 1, x squared stay there. Negative 3x plus 4x is a positive 1x, and then 7 plus 9 is 16. And you'll get the same exact answer if you were to flip them around and do g of x plus f of x. The piece where it becomes really important that we start using parentheses is going to be here when we start subtracting. So let's say we just want to find and discover, we'll do f of x minus g of x. We're going to rewrite the functions again. So we'll get 2x squared minus 3x plus 7 minus, and then I'll put the second set in parentheses, negative 3x squared plus 4x plus 9. And then here you'll see why we need a set of parentheses. And the reason is because when we distribute using a negative value, in this case it's this negative 1 in front of that set of parentheses, we're going to need to distribute that out, and that's going to change the sign of all of these values. So we'll get 2x squared minus 3x plus 7. Then we have a negative value multiplied by a negative 3x squared, so we'll get a positive 3x squared. A negative value multiplied by a positive 4x is going to be a negative 4x. And then a negative value with a positive 9 is going to be a negative 9. Doing the same steps as we did over here before, we'll start combining like terms. So we get 2x squared plus 3x squared minus 3x minus 4x. So I'm just doing the minus 4x's. I got all those. Plus 7 minus 9. So then I can simplify. Oops. I can write my answer as f of x minus g of x equals 5x squared minus 7x, and then you have a positive 7 and a minus 9, which is a minus 2. And this would equal something different if you flipped it and you had g of x minus f of x. I encourage you to go try that and see what you get. Okay. And then ultimately we have some sort of multiplication. There's two ways that we could do multiplication. I'll show you over here, and we'll organize them out. Okay, method one is going to be called the area model, and that's when you'll take both of the functions. So in this case, we'll do f of x times g of x. You'll take both of the functions and you'll organize them in a way that you can multiply them using a um, rectangle that has sections where you can organize the multiplication. So in this case, we'll have a 2x squared. This will represent our f of x. 2x squared minus 3x plus 7. And every term, so in each of these functions here, let me actually take this and I'll move, oops. Take this here and I'll move it over here. So every term in these functions, anything that's separated by an addition sign or a subtraction sign, so there's one term, there's two terms, there's three terms, every term gets its own column or row depending on where you're putting it. So then there's f of x, and then my g of x would fall on this side. So let me actually move this over so that way we have enough room. Move that here. And then my g of x would be on the side. So then I would have negative 3x squared plus 4x plus 9. And then each of those will get its own row. So if you look based off of the number of terms, because this has 3 terms and this has 3 terms, I will have 9 cells within this area model. Okay, now this method is really simple because then you can start organizing. Remember, we're multiplying, so then we can start multiplying all these values out. So we'll get negative 3x squared multiplied with 2x squared. So for this, we got negative 3 times 2, which is a negative 6. And then we have x squared times x squared, which means we have x to the 4th power. Okay, we add the exponents together here. Okay, and then we'll have 2x squared times 4x. 2 times 4 is 8. X times x squared is x to the 3rd power. And ultimately, we have 9 times 2x, which means we have 18x squared. We can keep going. We have negative 3x times a negative 3x squared. Negative 3 and negative 3 is a positive 9. X squared and x is x cubed, x to the 3rd power. We have negative 3x here and a positive 4x. Negative 3 times 4 is negative 12. X times x is x squared. Negative 3x times positive 9 gives us a negative 20. Oops, not 29, 27x. 7 times negative 3x squared is negative 21x squared. 7 times 4x is 28x. And then 7 times 9 is 63. So now you should have 9 different terms that you then can start combining like terms. And if you notice, there's kind of a pattern here. You have the biggest exponent, then you start getting smaller as you go diagonal, and then you go even smaller when you hit the largest diagonal there, and then you'll keep going with some x values, and then you'll finish off with a constant term. Now, you can look at these and you can simplify right away by doing it, but I don't like to get myself confused, so instead I just rewrite everything. So I'll get negative 6x to the 4th power plus 8x cubed plus 18x squared. I just write it straight down the columns. And actually, if we go back to that picture that we, the highlighting that I did, we can actually go from the largest exponent to the smallest exponent. Okay, so here I did this guy, negative 6x to the 4th power. I did 8x cubed, which means I need positive 9x cubed. And then I'll do negative 21x squared minus 12x squared plus 18x squared. And as you can see, my polynomial is getting very big because there's 9 different terms. Plus 28x right there. And then right here, we got minus 27x plus 63. Then you could simplify. I'll get negative 6x to the 4th power. I can combine these two, plus 17x cubed. I'll combine all of that together. So I get negative 21x squared minus 12x squared. This gives me a negative 33x squared plus 18x squared, which means I'll still be in the negative realm, but I'll get negative 15x squared. I'll combine the next two, 28x minus 27x plus x plus 63. And this will be my final answer when I multiply. So that's one way that you can multiply these. The second way that you can multiply is actually taking each of these polynomials and just doing distribution. So method 2 is just going to be distribution. And distribution makes it a little bit harder because you're doing the same thing as the area model up here, but you're getting all of the values in one line. And so you just got to make sure that you do everything correctly. So we'll do f of x times g of x, which means we'll have 2x squared minus 3x plus 7 multiplied with, and I'll just put them both in sets of parentheses, negative 3x squared plus 4x plus 9. And so method 2, when you're just distributing, I like to go one at a time. We're going to do this 2x squared, multiply it with everything in that set of parentheses. So we'll get 2x squared times negative 3x squared plus 2x squared times 4x plus 2x squared times 9. And so you'll see here that when I do that, I'm multiplying this first term with every term in the second set of parentheses. I'm then going to repeat that process with the second term. So then I'll get plus, this one's a negative 3x times a negative 3x squared plus a negative 3x times 4x plus a negative 3x times 9. So here I multiplied this negative 3x with every value for the second one. So if I use my highlighter, I'll show you really quick. 2x squared is here. I multiplied that with all the other values. Negative 3x is here, and I multiplied that with all the other values. And then ultimately, I'm going to take this 7, and I'm going to be doing the same thing and multiplying it with all of the other values. So just like before, this is also going to be kind of like the area model, but you're just going to organize it in a big polynomial instead. So here I'll get plus 7 times negative 3x squared plus 7 times 4x plus 7 times 9. And then you could follow the same steps as before. You'll simplify each of these by multiplying them, and then you should get the same answer that you just had up here. Okay. So this will be the first video serving as kind of just an introduction. This is kind of like the first 3 pieces of the functions final. So evaluating, adding and subtracting, and multiplying. This is all procedural. So the only thing you're going to need to be able to do is know when to use adding, subtracting, and multiplying for the polynomials that you have. So that way you can properly execute it on the final. So with that, I will see you soon. Good luck studying, and I'll catch you all next time.